And now you're live.
Hey, everyone. Thank you for joining our session today on how to master neural networks just in one day. And no need for any Python skills, doesn't matter what tech level you are. And it's all about being able to bring in production-ready models. My name is Andrew Gludt. I am the Director of Strategic Alliances here at Neuton AI. We're super excited to be here. What great sessions that we've had. I would first like to thank the Data Science Connect teams for making all of this happen. Without them, we would be nowhere. I'd also like to thank all of the participants who've been able to come in and join us, as well as all of the other speakers too. There's been a lot of great sessions and a lot of great ones coming up as well. So feel free to go ahead and use the chat function if you have any questions and everything like that, and we will address them as we go. So once again, thank you, everyone, and let's go ahead and get started. So today we are expecting a lot of different types of people to join this particular session. You could be technical resources where you're looking to explore and are new to the edge. Maybe you're looking at what tiny machine learning is. Maybe you're an experienced technical resource. Additionally, we may have data scientists, people who are new to AI and ML, or we may have very experienced data scientists. And then on the other end, we also may have business professionals who are exploring artificial intelligence and machine learning. So you could be a business user or a business executive. And so we are going to tailor this conversation to really touch upon all of the different aspects from business all the way to technical. So let us know if there's any particular questions that you have, and we'd be happy to address those in the Q&A as well. So for today, we're going to look at a little bit how Neuton AI is different within the industry. We're going to look at trends in the industry from a data science perspective, as well as artificial intelligence, and looking at what are their advantages with automated machine learning. Secondly, we're going to show you the way that you can easily build and train a model with Neuton AutoML. We're going to look at a practical business case, such as customer churn prediction. And then we're going to look at various different data and analytics tools that will be able to help you understand what your model ultimately is predicting on, what are the different features that are influencing those predictions, and how can you make actionable insights from that. After that, we're going to dive a little bit deeper into tiny machine learning and looking at how we can apply machine learning to the edge, and then how to be able to embed that use case, and then some Q&A. So once again, super stoked to be here, and let's go ahead and get started. So what is Neuton Automated Machine Learning? So we are a platform that allows you to create AI models with no code. There's no limits. It's artificial intelligence for all demographics. So our goal and mission is really to democratize artificial intelligence. We want to be able to empower business and technical resources to bring AI models into production quickly. One of the challenges we've seen is that there's a lot of time and laborious effort into creating these artificial intelligence machine learning models. And we would like to help bring those to fruition quicker so that you can get a quicker return on investment, as well as inherently the way that our framework builds these networks. It will always create extremely small and tiny models that will allow you to embed them on the edge. So our approach really kind of comes from three different perspectives: build fast, build once, and never compromise. And so what does that mean? When we look at building fast, we want to be able to provide something that's zero code, AutoML, that allows anyone to create these types of models. What does build once mean? Well, the neural network framework that we've created will automatically grow and learn and build extremely compact models and extremely powerful and predictive ones as well. And what does never compromise mean? When we build artificial intelligence models, we want to understand what the model is doing so that we can create not only business actions and insights, but change the way we do business in order to continue to make advancements and make our lives easier. So we'll look at different explainability tools as well. Model size or model quality. These are different things that we want to consider. Oftentimes, when we're trying to create small neural network models, we oftentimes have to compromise for model quality because we're going to do different things like quantization or pruning. And so with what we're doing, we will be able to create with models with fewer coefficients and neurons. It'll be smaller in size and faster in inference times. And so with our benchmarking, we've seen our models be able to build up to 1,000 times smaller than other frameworks that we've seen and tested on the market. Where is machine learning headed? This is a very interesting question. And what we've seen from the evolution and automation, not only within the AI and machine learning industry, we are also seeing it across all industries. So if we look at cars over the last 20 years, they've become much more automated. They're becoming much more convenient and even autonomous, all leveraging artificial intelligence and machine learning. That's not the only industry. Look at retail as well. The ability to do automated checkout. All of these things are becoming more and more automated. If we look at, the financial industry, being able to, use ATM machines to be able to get access to your funds without having to talk with somebody at a particular branch. Even we look at the space industry as well, rockets being able to land automatically on their own. And this evolution that we're seeing, we believe within the next 5 years, all of the data industry will be extremely automated. And this opens up the opportunity for a lot more people to be able to understand their data, leverage their data, and ultimately get value back from their data. This is what we see data scientists now being able to leverage data science. So all of these different types of models and tools and skills that you need, from statistics, data pre-processing, feature engineering, linear regression, logistic regression, all of these things and topics that have been discussed before. These are the types of tool sets that you would traditionally need to become and leverage data science. Additionally, you need coding skills, whether it be Python, R, Java, SQL, as well as analytical tools, the ability to work with IT and data mining too. So this is what we see as what data scientists are now today. And when we look at jobs and roles in the data industry, we do see a gap between data analysts, from data engineers to data scientists. When we're looking at what the salary ranges are from, say, 70,000 to 171,000, how can we help the data analysts, the developers, the scientists be able to leverage machine learning as well as increase their value in the market, and thus increasing their ability to look at new types of careers and also help expand the career opportunities. One of the big problems that we've seen is the implementation of artificial intelligence and machine learning. Not only do we have to prepare the data, not only do we have to process the data, build the models, and ultimately try to implement the models into production so that the enterprise can gain value for that. And did you know 90% of all machine learning models never even make it into production? So when we look at it, 1 out of 10 data scientist workdays actually end up producing something that's very useful for the company. And so what are the challenges that we see? What are the things that companies are really lacking to be able to bring artificial intelligence into production? Leadership support. When we look at the C-level organization, when we look at the VP level organization, even to the director and manager level, we need the support to be able to understand what the data is that we're working with and how we can bring it into production so that we can ultimately get value back to the company and be able to provide bottom line revenue. Effective communication is another area that we see. When it comes to talking with the data scientists between leadership, whether it be engineers and data scientists, or even the business teams, it's extremely important to be able to have a very good and effective communication stream between business and IT, data scientists, and engineering. Without that effective communication, it's extremely difficult to be able to find the right type of use cases that are going to provide value back to the business. And also, when we look at what are the different types of machine learning models, are they feasible to bring into production? Are they desirable? And ultimately, are they able to bring return on investment back to the company? Finally, another area that we're seeing is the accessibility of data. When we look at our different types of systems that we have within the organization, it could be your CRM, it could be SAP, it could be Oracle, it could be other backend systems. Being able to get all of those different types of pieces of data is very difficult to get. And did you know that Netflix created a $1 million algorithm and never even brought it into production? So this just further validates that it is very difficult to bring these different algorithms or AI models into production. Another problem we see when we talk about data preparation, it's all about the quality of the data that's coming in to the creation of the model. If you don't have good data in, then the model and the predictions that you're going to have are not going to be as effective as they could be. So when we look at Accenture, they created some different types of surveys and everything like that. And they came up with this really interesting quote. So AI-driven upheaval will place a higher premium on what we call judgment work, the application of human experience and expertise to critical business decisions and practices when the information available is insufficient to suggest a successful course of action. This kind of work will require new skills and mindsets. When we look at data preparation, pre-processing, when we look at what are the types of business decisions that we need to look at new types of skills and mindsets that we can bring in and upskill to bring value back to the business. And that brings us into the third problem is, what is the right type of focus? From our career perspective, what are the different types of tools or mindsets that we need to have to be able to more effectively bring in artificial intelligence into the organization? When we looked at this particular survey, we found 42% was digital and technology. And then if we look at the next three, creative thinking, data analysis, as well as strategy and development, are other types of skill sets that we can bring in. So not necessarily just focusing on the ability to code or use Python or R or linear regression, as we saw before. We also see things like social networking, people development, and collaboration. The ability to collaborate is extremely important because we need to create the connection between business and technology. And on the right, we can see social intelligence on the y-axis and creative intelligence on the x-axis. If you look at the bottom left, this is more where there's the machine advantage. So those redundant activities and tasks work really well for bots. If you move more to the top right, you see the human advantage with higher social intelligence and creative intelligence. And we can actually augment this with the machine advantage as well. So what do you need to learn today to tomorrow? This is extremely important as we move through our career, as we move through our lives. As we saw earlier, What we saw was the data scientists of today. You've got your data science, your coding, data mining, MIT. But what in the next 5 years are going to be important? Business domain expertise. When we look at what are the different types of industries we work in, what are the different types of business units within those industries, all of those will slightly change the type of AI and ML use cases that you're going after. Business problem solving. How can we look at what are the problems that the business is having and what are the things that we can do to help create predictions so that we can be proactive as opposed to reactive? Creative thinking, going out of the box, working with different people, being able to look and see and understand what the different types of challenges we're understanding and how we can start to create solutions around those. Communication and leadership skills. This is extremely important. The connection between business and IT can help a lot when coming to getting the data, being able to prepare it and create it and ultimately implement it. Having the right type of mindset, being able to do project management and agile methodology, and network. So what is the old way of being able to implement artificial intelligence? Okay, so we have a project idea. Well, now we need to find data scientists, which is extremely difficult. It takes a lot of time, takes a lot of resources. There aren't enough data scientists for the market, and also attrition of employees is very difficult. Then you'll need to set up the infrastructure, analyze the data, process it and clean it, maybe do feature engineering. Then you'll do your modeling. You'll find your developers to be able to bring it into production. You'll deploy your model, and all of a sudden bad results and you have to start all over again. Or maybe it all worked out perfectly and you're able to start making predictions. Well, when we look at it with Neuton, we start with the project idea. You upload your data, you select your target variable, you train it, and then you can start making predictions. This can help you bring your models into production up to 10 times. It can reduce the cost up to 70%, and the support costs are extremely low. So you'll be able to create AI experiments with just 3 clicks, which data pre-processing and feature engineering is fully automated. When we look at automated machine learning, it's pretty much the Excel of machine learning. So initially you would do some calculations on paper. Then maybe you can do some calculations on Excel. Now with the Neuton framework, you can create neural network models with the platform just as easy as creating a simple formula in Excel. So what should data scientists do to prepare data for machine learning experiments? Well, we have exploratory data analysis. How can we look at all of the different features and how they're influencing your predictions? Pre-processing. How can we clean the data? Maybe we need to fill in missing values. Maybe we need to do sampling and data normalization. And even there, to make the models even more effective, doing feature engineering. So combining features based on linear modeling, based on tree modeling, all these different types of things. These are a lot of different activities that we have to do just to get up to the point where we can begin to build our model. And so with the Neuton automated machine learning platform, we're able to do this automatically. So let's just jump right in and check out the platform. All right, so this is the Neuton platform. Everything is completely cloud-based. We're a technology partner of Google Cloud. Here on the right, all of the solutions and AI models that we create are tile-based. And so we can create as many different experiments that we want simultaneously. And all the provisioning of the GPUs and CPUs is done for you, so you don't have to worry about any of those types of things. Over here on the left side, we have different preloaded use cases. We have where you can check out all the different data sets that you have on storage, as well as an extremely comprehensive support library. So along any step of the way, you can go here and be able to understand what are the different types of metrics within my model. What do they mean in layman's terms? And here I've created a couple of different experiments already, but let's just look at the entire workflow. So up here in the top right, we have what we call add new solution, or creating a new solution. So here today, we're going to want to predict customer churn. So whether a particular person will stay with the company or not, whether they'll continue to be a customer of yours or not. And then also, what are all of the different things that are influencing that particular customer? All we'll need to do is click next. You can upload your data set from your computer. You can select one from your storage, or you can use one of the many preloaded data sets that we have here across different industries. So I'll go ahead and upload a data set. Here I have a couple of different data sets here. For customer churn, I have two data sets. The first data set is the train data set. So this is going to have all of the different pieces of information about the customer and their behavior, as well as the predicted value, churn or not churn. This would be a binary classification. So if they churned, it would be a 1. If they did not churn, it would be a 0. The second data set that I have is our test data set. This would be all of the new incoming data that we have that we're going to want to predict on, and then that we're going to want to create business actions in order to help prevent that customer from churning. So right now, it's going to quickly look at the data set just to make sure that it looks fine and it's able to use within the system. And then here we'll just take a quick preview of the data set so you kind of can understand of the different things. So we've got their credit score, geography, gender, age, the balance that they have. This is for a bank, and their estimated salary and whether they churned or not. Here we can see that this particular data set has about 8,000 rows. And we will click OK. As you can see, there's 3 pretty easy steps: data set, training, and then prediction. Here in the data set, we've uploaded our data set that has all the historical data as well as whether they've churned or not. And now we just need to select our target variable. And in this case, it's churned. Click next. Here, the Neuton platform has understood that this is a binary classification problem, and the metric is accuracy. However, we can choose different metrics. And like I had mentioned, if you're unsure of what particular metrics mean, you can go to the support tab. In this case, we also have an advanced mode as well as a tiny machine learning mode. Today, I won't go into details of that, but here you can just click Start Training. So what this is doing is we are now spinning up CPUs and GPUs for data pre-processing, feature engineering if we were going to do that, as well as the GPU for training. Also, if you like, training may take up to a couple of minutes or hours, so you can put your phone number in here and we will text you when the training is complete. In this particular case, I won't have all of you sit here and watch the model train. It's not that interesting. So what I've done is create an experiment with the same data set, but I've already trained it so that we don't have to wait. So this is what it will look like once the training is complete. We can see it took 13 minutes to create a model. In this particular case, we were going for accuracy, and so we've got an 88% accuracy. We also provide a model quality index, which is the weighted average of all of these. Partially through training, we can look at some of the different analytics tools that we have. When I mentioned earlier, the skills that you need to leverage before creating an ML model was exploratory data analysis. and we've automated this process for you. We can look at all of our data overview. We've got different types of data. We have integers, we have text, we have float. In this particular case, we're looking at continuous data. So let's see here if we can find an interesting one. Here we can look at the balance. So somebody's balance at the bank in relation to whether they churned or not. So we can see the distribution higher or lower depending on the balance. And in this particular case, 1 means churned and 0 means not churned. This is some information for you, as well as the discrete data or the categorical data. This would be, for example, the different locations that the customers were in, whether it was France, Germany, Spain. And on the right here, we can see the target not churned is 0 and churned is 1. We could look at this particular market, Germany, and we can actually see about a 50% distribution of churn versus not churn. So we could potentially look at what we're doing in this particular market to see if we can make any, or we can look at Spain, for example, that has lower churn versus higher not churned. And then we could apply that information to Germany, for example. This will show you the distribution between churned and not churned. And we also provide a correlation heat map. On the bottom here, we can see how the target is correlated to the different features. So in this case, age is 28% correlated to the target. And we can also look at the multiple different features. So in this particular case, we have geography and balance being highly correlated. If these numbers are approaching 1, it may give us some indication that there may be 2 features that are extremely similar, and we might want to remove them from our model. Here are just a few different examples of the exploratory data analysis, which is part of our explainability office. If we're doing different types of problems, whether it be regression, time series, natural language processing, there'll be different types of analytics tools. Finally, once the training is complete, this is kind of where it gets interesting. This is where we're able to create predictions. Over here on the right side, we have prediction, and I'll start from the bottom up. Here we have our downloadable solution. So if you want to be able to implement the solution into a microcontroller or device, or even a local system, you can just click download, and we'll provide all the necessary C code in order to be able to implement it, as well as all of the different weights for the different features. We also have the ability to do REST API. If you want to be able to, say, for example, call predictions once a month to predict the potential customer churn, we provide some sample code as well in order to be able to do REST API. The most interesting part, I would say, is our web prediction. This really will allow the data analyst, the business analyst, to be able to come into the platform, upload their new data, and do predictions, and also be able to look at the data. So all you need to do is hit this button. I've already enabled it. Sometimes it'll take a few minutes. And then you'll click start, and then you'll upload your data. So before I uploaded the customer train, now I'm going to upload my customer churn test set. So this is all of the customer data, not included the target variable. I've already uploaded it, and we'll take a look at that now. Everything to the right is what we uploaded. Everything from the model to data relevance indicator to the left is what the Neuton platform has produced. These are the individual rows in the test data set that I've uploaded that Neuton has predicted. So in this particular case, for row number 1, the customer did not churn, and we have a 97% probability. So there's probably nothing I really need to do about this because they are most likely not going to churn. In row 4, this customer is to be predicted as churned with a 75% probability. In this case, we might want to look at customer 4, Joe, John, Mary, whoever it may be, and take a look at why or what actions we can do to prevent them from churning. Let's leverage the model interpreter. In this particular case, we can see that the customer churned with a 75% probability. In this particular case, the customer has one product and a 75% chance to churn. In this particular case, if the customer had 2 products, there would actually be an 83% chance that they did not churn. What are the things that we can do to help get our customers more products in order to reduce the chance of churning? We can look at balance, depending on how much they have in their account, potentially their age, as well as the categorical features here, and gender as well. When we look at this, what we call our feature influence, the steeper the slope, each incremental change we make will have a higher change in the predicted value. The last thing I wanted to show you within the platform is what we call our feature importance matrix. Under Analytics tool, let's take a look. What this will do is help you understand what are the features that are influencing your prediction the most. And this can be important from a business perspective. So the number of products is extremely important. Their balance within the bank, what their age is, their credit score as well. So we can look at the top 10 and we can also look at the bottom 10. So in this particular case, the row number, customer ID, whether they have a credit card, didn't really make an influence on the prediction. In some cases, you may need to be purchasing data in order to create models. In this case, we might not want to include this in a future model, as well as we may not even need to collect that data and incur that cost. Lastly is our historical data model to data relevance indicator. And so what this will help explain is whenever you create new predictions, you want to make sure that your model is still relevant. If the model is not relevant, then we may lose out on revenue or whatever it may be we're trying to predict if a customer is going to leave us or not. In this particular case, the data that I recently uploaded is 98% relevant. If this begins to decay, say down to 70%, the leaves on the tree will start to fall off and turn yellow and will indicate whether or not you may need to retrain your model. This is basically a lifecycle management tool that you can leverage as well. Awesome. That is the Neuton platform. So thank you all for taking a look. And if you want, you can absolutely use this platform for free to try it out. All of the different features that I showed you, from exploratory data analysis to the feature importance matrix and even the model interpreter, are all available in that free version. So you can just go to lab.neuton.ai and click start and register and try it out. In summary, the Neuton AutoML main advantage is it's extremely cost effective. It's simple to use. It allows you to bring AI solutions into production faster, creates a smaller or shorter model update cycle. It helps you be able to understand the types of models that you're making. It's fairly easy to integrate as we provide a lot of the code automatically. And it's easy to manage the solution from an end-to-end perspective. Lastly, from what we're going to cover today is a little bit about tiny machine learnings. This would be our Neuton TinyML novel approach, how to train and embed your model, and then we can go into Q&A. Our novel approach to building exceptionally tiny models. We've been able to take a new approach to creating neural network models. Traditionally, you would start with a large network that's predefined. You would then do different hyperparameter tuning. Once you've got your model where you want it to be, you would then start to prune the model, do quantization to make the model smaller to be able to embed into an edge device. We've now taken a bottom-up approach where we start with a single neuron. We understand the connections between the features. We cross-validate it, add another neuron. And once we get to a point where we are fairly or extremely accurate, the model will be ready and stop training automatically. And this will provide with an extremely small model. So what is TinyML? How can we bridge the gap between reality and digital? When we look at edge computing, so many IoT devices, our cell phones, our Fitbits, different sensors that are detecting things, are even our vehicles. Then we have the world of artificial intelligence, which means a lot of different things for people. When we look at how can we replicate the way we think as a person and have the machine do that for us so that we can focus on higher value tasks, we then can bring in machine learning, has started to bridge that gap between artificial intelligence and edge computing. Finally, TinyML sits in the middle that can really connect artificial intelligence and being able to deploy that on the edge. What are the main barriers and challenges for creating extremely small models? The availability of resources, being able to integrate large machine learning models into edge devices, and finally, being able to evaluate the quality and understand the logic behind the model. These are the three top main barriers and challenges we see. So what if you could build a model without having any technical expertise? Can you create a model with 3 clicks? Can you find the most optimal model in one iteration? Can you produce models up to 1,000 times smaller than TensorFlow Lite? Run inferences 60% faster? Eliminate the need to perform compression? Explain why your model makes every single prediction? How can you accelerate your time to market for your AI models by 85%? And build fast, build once, and never compromise for accuracy. So the traditional approach that we see to embedding models would be to start with your business requirements, identify the hardware, then create a model manually, then do compression, pruning, distillation, quantization, embed it within your microcontroller, evaluate whether the accuracy is good, and hey, can I trust this model? It's 100% accurate. It's 100% manual effort. It could take months, and you may need 4 different skills. So what next? How do we create these compact models without compromising accuracy? Let's take a quick look at a video.
Whether you're building dynamic network models or forecasting real-world behavior, Neo4j's new...
How does Neuton create incredibly compact and accurate models? First, Neuton uses a selective approach to the connected features. Let us take as an example the model for determining cardiac arrhythmias. Amplitude of contraction of the heart muscle acts as one of the features for training the model. As you can see, Neuton only needed to make connections with half of the features. We also leverage a unique patented algorithm to adjust the coefficients within a model. Unlike most algorithms, Newton's algorithm is not based on backward propagation of errors and the stochastic gradient descent. Furthermore, the Newton algorithm is minimizing the likelihood of hitting local minima. This is especially important when building small models. You can see that in our example we've achieved an area under the curve value of 0.96 with only 253 coefficients. Meanwhile, achieving the same accuracy with TensorFlow requires significantly more coefficients. Neuton is even 10 times smaller than TensorFlow Lite. The Neuton platform enables models to be built automatically, neuron by neuron, starting from learning general features and moving toward identifying the most specific ones. This allows selection of a model of almost any level of precision and size in a single iteration. The Neuton eliminates the time-consuming multidimensional manual search for network parameters including number of layers, neurons, type of activation function, batch size, dropout, learning rate, and more efficiently finds the optimal structure. The neuron by neuron growth makes it possible for cross-validation to occur progressively, which is typically not feasible with a standard approach. The combination of these characteristics also increases the generalizing capabilities of the model, which allows for creation of compact models without compromising accuracy.
All right. Just as an overview to the video we just saw, we take a selective approach to the connected features. We automatically create the network neuron by neuron. There's no need for manual search for neural network parameters. We have a unique and patented global optimization algorithm, and we do cross-validation on each neuron. When we look at our future today, how can we apply this? We don't do any back propagation of errors or stochastic gradient descent. We don't have problems with local extremes and plateaus. We can help significantly improve the neuron's efficiency and reduce the network volume. There are a lot of different benefits to having this global optimization algorithm. And when we want to embed these into edge devices like ARM, for example, Newton's model can be built to fit any type of microcontroller, whether it's 8, 16, or 32-bit. And also it requires very low energy processing power as well as memory. When we look at the old model for, say, TensorFlow, where we'll create the model, we'll do that manual search, we'll do compression, and then ultimately embed it into a microcontroller. This could take lots of effort and lots of skill profiles. With Neuton, we can create the model automatically and embed them into the microcontroller with only maybe an hour of time and one skill profile. Now let's take a look at embedding the AI model into a microcontroller leveraging Neuton.
Students with ADHD save 10 hours studying with this Chrome extension. But no.
Let us take a look at an example of a model used to determine cardiac arrhythmias from cardiogram data. We would like to leverage the created model to predict whether there is an impending arrhythmia or not by running inferences on the microcontroller, without sending the corresponding sensor data to the cloud. During this process, we will show the complete life cycle from training, leveraging Neuton platform, to successfully embedding the model in a microcontroller. In addition, we will show the same process while leveraging TensorFlow. So, in order to train a model on the Neuton platform, you must simply load a CSV file with historical data, in this case various cardiograms, where arrhythmia is noted. The file contains more than 11,000 rows, amplitudes of contractions of the heart muscle act as features for training the model. We select the appropriate task type and target metric. Neuton provides a number of settings to work with microcontrollers. In this case, we choose 8-bit depth support, then we start training. At this point, everything else happens automatically. Our manual effort to get to this point is minimal at best, oftentimes less than 2 minutes. At this time, the training on the Neuton platform has concluded. Upon completion, we have realized the following model characteristics. Area under the curve equals 0.96, a model size of 0.7 kilobits, and with the number of coefficients totaling 253. This is an excellent result. Now our model is ready to be embedded into a microcontroller. We begin building a network while leveraging TensorFlow. We first begin by looking for the optimal architecture while also looking to sort out the associated parameters. Here are a list of other potential settings that must be handpicked and validated. This is a long, random, and laborious process that does not guarantee finding the optimal structure. We will show the example and results if just one of the many available parameters are selected for the given network architecture. This absolutely cannot be done without special training. In addition, we must spend several hours iterating over these parameters. We begin by initializing the network with one hidden layer, after which we will train and validate the model. We have set aside 20% of the training data as a holdout set for validation. Now that the network is trained and validated, we can see that we have achieved a model accuracy of 0.857 measured with the metric area under the curve. This now becomes our baseline. Let's add one more hidden layer and see if it will improve our results. To see the updated results due to our changes, we must train and validate the model once again. As a result, we can now see that our accuracy has increased significantly, and the measured metric has increased up to 0.96. Let us now change the activation mode of the previously added layer from ReLU to 10H and see what happens. As we know, this is a random and iterative process that occurs when building a model. We now see that our result has decreased in comparison to the previous iteration. Let's discard the activation change from the last step, since ReLU clearly provides better results. Again, taking another step in the iterative and manual process of model building, we will now add another 3 hidden layers, all with the ReLU activation function, and see if this will improve our metrics. We can see that our new score is now 0.956, which is a clear indication that our resulting model is overfit. Let us now once again change the activations of the previously added layers to 10H. In this case, we can see that our model got stuck in the local minimum. This time, let's change the activation of just one hidden layer from 10H to ReLU. We can see that our model has once again experienced overfitting. After reviewing the previous 2 iterations, we can easily draw the conclusion that our model from 2 steps ago produces the most optimal results. Here is a summary of all the differing and necessary steps we took in order to identify the most optimal model. After several hours of iterating over various parameters, we created a model in TensorFlow with similar characteristics as it relates to model accuracy. However, the model size is indeed much larger than the results we would typically see with Neuton. Neuton's model is 47 times smaller than TensorFlow. However, you cannot embed model immediately. We need to reduce it using the TensorFlow light converter. We can see that the firmware does not fit into the flash memory of the targeted microcontroller. Therefore, by reducing the list of operations that the interpreter supports, you can reduce its size. In order to accomplish this, we must open the main_functions.cc file and change all ops resolver to micromutable op resolver. Our model requires only 5 operations. Compiling it, we see that the size has decreased. But Newton's model is still 10 times smaller than TensorFlow Lite model. Now our model is ready to be embedded into a microcontroller. Next, we proceed with opening the archive folder for microcontrollers, which contains all the necessary files, which simply can be transferred to the microcontroller's firmware project. Now to compile the project, we need to press the build button. After the compilation is complete, we then press the debug button. The program will then proceed to be loaded into the microcontroller. Click Stop. Everything is ready to run inference in the microcontroller. Next, we take data from a digital cardiograph as input data and transfer it to a microcontroller. If the red light comes on, then an arrhythmia is detected during the reading. Now we see that the green light has turned on, which tells us there is no arrhythmia detected with this particular reading. We see that the light has now turned red once, which tells that everything is once an anomaly within the reading has been identified. We perform similar operations for the TensorFlow Lite model. As we can see, most of the time was spent on manually selecting the neural network architecture, selecting parameters and converting the model, compressing it, and reducing the number of operations. Now let's summarize the results. We see that with the help of Neuton, we managed to automatically, just in one iteration, build a model that is 10 times smaller than even TensorFlow Lite. It utilizes 3.5 times less RAM. It demonstrates 2.5 times faster inference time. We also considered other comparable solutions such as Edge Impulse, which has TensorFlow Lite under the hood, however eliminates the usage of an interpreter to decrease memory usage and inference time. Nevertheless, we still experienced lower model accuracy and increased inference time, and still a materially larger model size than Neuton. And most importantly, working with Neuton does not require any special qualifications and implies little human effort to launch similar projects. Neuton's model allows predictions to be made at 2 milliseconds, which is almost 460 times faster than the average heart rate.
Awesome. In summary, as you can see, if you were to do this entire process with Google TensorFlow and then converting it to Google TensorFlow Lite, lots of programming, lots of random different types of processes you have to do, and then eventually embedding it into the microcontroller. With Neuton, we're able to accomplish this with just a few easy tasks. And in summary, you could see some different benchmarks between the Neuton platform versus Google TensorFlow Lite and even Edge Impulse as well, as we saw in the video. Once we embed the model into the device, what's next? When we look at what my colleague Blair Newman, our CTO, calls the 4 W's, we should ask ourselves, what does my data consist of? Where are the important features? Why does my model make certain predictions? And when should I consider retraining my model? This is where we can look at the exploratory data analysis we saw in the Neuton platform. This is showcasing the different outliers. What are the important features that are influencing the predictions? How can we make incremental changes to change the resulting prediction? When we look at the model to data relevance indicator, do we then determine that we need to retrain the model? All of those questions I asked earlier can be answered with the Neuton AI platform. So yes, we can build models without technical expertise. We can do it in 3 clicks. We can build it fast, and we can build it once, and we never compromise. Earlier, we saw some challenges from a staffing perspective, taking large models and compressing them, as well as understanding the model. Neuton addresses this with a zero code platform that's made for non-data scientists. The neural network framework that builds extremely compact models in one iteration, as well as the explainability tools for comprehensive model evaluation. So thank you all very much for joining us today and going through what we're seeing in the market, the Neuton demo, as well as what we're doing in the TinyML space. Thank you to the Data Science Connect staff for making this all happen, as well as everyone who's participated or speaked into the event. Feel free to add me on LinkedIn. I'd love to connect and we could talk a little bit deeper. And there were a few questions in the chat, so let me see if I can pull those up. So feel free to ask any questions that you may have in here, but I'm going to start with Fatima if they're still around. Build once, does that mean it will use some sort of reinforcement learning and be able to improve on its own? Neuton leverages our internal developed patented algorithm that has a particular framework that builds those models neuron by neuron. So hopefully some of the videos were able to answer some of your questions. And of course, all of the recordings will be available after the broadcast that was answered. And then Mihaj, we can definitely connect on LinkedIn. Shyham, interesting approach. Do we support computer vision models? Right now, we primarily only work with tabular data and accept CSV files. We are looking at bringing audio and video into the platform in future releases. Neuton doesn't answer on the significant time consumed for data preparation from multiple data sources. Absolutely, Lim. This is a huge problem, that we see from a data preparation perspective. So you're absolutely right. It does help with data pre-processing, so some of those missing values and things like that as well. Yeah, I'll just give a few minutes more here if anyone thinks of, any questions or if they have any comments and things like that. How Neuton excels Google AutoML. Yeah, we have a few different differentiators from our explainability, from having to have low code as well. Yeah, Lim, no worries. Happy to share with you. Like I had mentioned, let's connect on LinkedIn. I would love to learn about, your interests in automated machine learning or just AI in general. And we're constantly doing different types of events. We're going to be doing some masterclass events coming here in the month of November. So we're going to have probably 7 or 8 really good sessions. And we're going to have speakers from Microsoft as well as AI Guild and some others too. So keep tuned in with us, and we'll be constantly developing our platform. We'd love you guys to try it out for free as well. You can go on to our website, sign up. We have a completely free test drive version where you can access all the features of Neuton, as I had mentioned. And then if you want to look at how you can bring in models into production, we'd be happy to talk with you. We have a really solid data science team that we support our customers with as well. And we also have a nice Slack channel that our customers and our free users can ask us questions, and we're happy to answer them, whether they're general AI questions or other types of questions as well. Cool. We'll just give it 2 more minutes, and we'll have some time left over so everyone can stand up and stretch, walk around, grab some coffee or water or whatever works well. So yeah, thank you so much for hopping on the line. It's great to meet all of you. Hope you have a great rest of your day. Yeah, absolutely. How can we reach you? You can email us at Neuton or welcome@neuton.ai. You can also message me directly. It's my first letter and last name at Neuton.ai as well. I'll go ahead and type that in chat. Oh, perfect. Thank you so much. Alrighty. Well, thank you everyone for your time, and hope you enjoy the rest of your Data Science Connect adventure. Yes, we can share our slides. Please shoot us an email. I'll send those over to you. They should be available after as well. Thank you, Laverne, Bay, and everyone else.